Okay, I will start the today's lecture. I hope you watched the video I prepared. It's just a simple introduction. Today will be today's course will be about the factor function and space curve. Please watch. Okay, the intro on YouTube. The link is provided in Moodle. Let me give you an example. Find factor function. Okay, so you have two curves, at least two shape. Okay, x squared plus y squared equal 1. What's the shape? But in 3 dimension, cylinder, right? Y plus z equal to y plus z equal to, but in 3 dimension, plane. Okay, it's plane. So how to find a factor function that represent these two intersections? Okay. So we need to find any idea. Okay, we need to represent we need to find parameter t to represent these two functions. So if I write x squared plus y squared is equal to 1, if you remember, if you have sine squared theta plus cos squared theta is 1, right? So imagine this as this x is my cos t, okay, and my y is my sine t. Okay, if I make x and y as cos and sine of parameter t, then it should be fit with the x squared plus y squared equal 1, right? Yes. Okay. And I need to set my t, and then start with the y plus z equal 2. I can make my z 2 minus y, where my y is actually already defined as sine, right? So I can write also. So the factor function will be cos t. If you want to write ijk, so I plus sine t j plus 2 minus sine t. Wait, I need to. Okay. If you're wondering what kind of curve, you can try to draw. So if this is 1, and then y plus z equal 2, so it's in yz plane. So 2 is here. So what kind of curve will be? So you see the blue line is actually a plane. So I need to extend this as a plane. Okay, see the plane like that, like that. So imagine you have a cylinder and you cut the according to the line. You cut that cylinder. So you will have let me write it, or I will write in black. This cut. Okay. It's not really smooth, but imagine this cylinder is cut by the plane. So that's the intersections. So the vector functions, this what we find before, is exactly what is the intersection between the cylinders and the plane. So in the middle of the cylinder and plane, it has the like this. Okay, and it has some directions. If you feel confused because you don't watch the video, the introduction is in the video, so I don't want to read you again. But it's just a small introduction, just a 20 minutes introduction. It's really, really fast. So I believe you can catch up. So vector functions, okay, basically the domain is the t, the parameter t, it's its domain. The outcome is the vectors. So if you input the value of t as the domain, and then the outcome is the whole vector function itself, the vectors. Yeah, it's in the intro. I still remember how to determine domain. Yeah, domain. Yes. Remember, right? Yes. Okay, I will go to the next page. We finish. Okay. So domain. If I have my vector functions, you can also write in terms of vector. Let me write. So for the how to write the vector functions, it's up to you. You can write the I, J, K, or you can write like this. Okay, it's all the same vectors. So what's the domain for the vector functions? So first, we need to see one by one in X, in Y, and in Z, right? I think the easiest one is Y, e to the t, right? Then the domain is what? T should be all real number, right? All real number. So you can plug in all t, negative, positive, all numbers fit with the t. Okay. And then z. I think z is also not too difficult. Square root of t. So below the square root, it should be what? So, right? Okay. Zero. Oh yeah. And x is ln. Remember, this is the absolute value. So domain. Remember, it has absolute value. It's different from this. It's different. If in this case, then you need to be greater than 0, right? But here, yes. So uh, t is not equal 1, 1, 1, right? Yeah, 0 is, you cannot define ln 0, right? Yeah, cannot be 1. But all, because it has absolute value. So negative is still fine because it has absolute value. So the domain of the function, all the function, the factor function, it should be include all the each parametric domain, right? So it's greater than 0. It's not equal 1. So I can write this as, so I cannot write any negative, right? It should be greater than 0, right? At least. So at least I have 0 until 1, but it's not include 1. And then from 1 to, you have infinite. Still possible. So again, the domain in factor function, the domain is the t, okay, the parameter. Yes. No. Infinite has no number. You cannot define any infinite in exact number. Okay, I will give you, let me give you some examples from previous graphing. Okay. I will write some examples. Find a factor. It's the same case as the first case, okay, that represent the curve of intersection. So you have two surface. See if you can understand what does it mean. It's basically the same as our previous questions, the very first questions that I gave. So for the A, x squared plus y squared equal 4 is cylinders. Okay. But for B, what is the surface? Z equals square root of x squared plus y squared. It is the same as the z squared. Remember this? What kind of surface? No. Yeah, cone. Cone. Yeah. Cone. So to solve A, let me write the x squared plus y squared equal 4. Basically, in the base and at the top and the bottom, it will be circle, right? Circular. So to fit the equations, we can set our parameter, right? X is equal. Any idea? Not 4, 2. Yeah, because it needs to be squared, right? Do you know how come cos and sine? Yeah. From there. And then why you need to include 2 here? Because you want to make it this square. It need to be equal 4. So that's why it need to be 2. And then you can have it's 1, it's 4, right? So you can have x is 2 cosine t, y is 2 sine t, and then the surface z is equal xy. How are we gonna do this? And then I need to set the t also. So because the surface, the z, is also lie in the same curve, because it's intersect each other, then I can write z as right. So I can write 2 sine t cos t is sine 2 theta. So I can write this. So my vector function will be okay. And how about number B? Um, no. Some of the questions are really difficult to draw. I already showed in the video in the last, I think in the last example, it's quite difficult to draw. But at least you can make some approach, make some projection in each plane. Yes. We can substitute and then make it equal because it's already solved with z, right? So number B, because it's already solved, right? So we can make the equations and then we can just square both of these equations. So you have, right? And you can remove this. And then you can have x squared, or I want to make it in y. So this is my y. Okay. So what's the next step from here? We need to assume between x, y, z, you can change into any equation you want. Or you can exchange x, y, z with t. But you need to choose appropriate t so that all the equations are correct. So in this case, okay, see this y here, okay? The y itself, it has x squared inside, right? So what if, so I can say let x is equal t. So my y will be, okay, and my z, 1 plus and then solve this is half t 1 minus half is half, right? So it's actually this. So you can write the vector function t half, and then so if you want to reparameterize any functions, you can start with any x, y, z, as long as it is consistent and it will be correct in all equations. So you can do that. Yes. Hmm. No, it's just to prove that our assumption is correct. It is just to prove. I think it's still doable, right? It's still related to the factors, right? Especially the surface. Okay. Okay. The next one, I will go for limit and continuity. So if my vector function equal, let's say f, g, and h functions. So then if I evaluating limit, for example, t, let's say a of my vector functions. So meaning you need to evaluate all the limit in each function. So as long as three functions or let's just say limits exist, okay, so if you can still remember how to do the limit, I give you some one example.
Kalau aku pakai IJK berarti aku harus lulus plus.
Okay, remember limit is easy, right?
As long as three limits exist.
So you just evaluate each functions and evaluate the limit. It's too small. Yeah, one by one, finding the limit. So limit t So what's the first one? Huh? Yeah, 5, just 5, right? I'll write in I to make a variation so that you still remember how to write. Okay, and the second one, 1 minus cosine t over t. Okay, here's the thing. Okay, any limit, the first thing you need to do is plug in the number. Okay, plug in the value, and then see the result. If you plug in and then the result is 0 over 0 or infinity over infinity, then you can do L'Hopital rule, just as easy as that. Okay. But if it's not 0 over 0, you need to just use any number you find. Why 1?
Because T is 1. Oh, never mind. Now T is O.
So if we do L'Hopital rule, I'll write here. If you do L'Hopital rule, so minus cosine t, you need to derive, and it will be sine t over 1, right?
And then sine of 0.
Sine of 0 is 0. Yeah. And then the third one, we plug in the 0, so it will be ln 1 over 0. ln 1 is 0, so 0 over 0 situations. So the same thing, we do the L'Hopital rule. So ln will be 1 over t plus 1. T is 1, so it's only 1 over t plus 1. So plug in 0, it's 1, right? So the y parametric is 0, so I'll just write plus k.
So we can't forget. So when you y is named plus k for J.
Yeah, because j is 0, right?
Oh,
So I don't need to write. Or if you want to write maybe 5, it's also the same. Okay? I try to reduce also. Sometimes reduce, or I mean I cut some part. Okay, next part. We go into the derivatives. So definition is so all these terms, okay, all these terms are valid. You can write with any terms you want, okay, as long as you are fine with it. Okay, so these terms are okay. And then we start by the definition of the derivative itself. By definition, derivative is the limit, right? Remember? So limit as h going 0 So it's better to give you some visualizations. So you have curve. So this is the vector function r, and this is r t plus h. So you have this gap between t plus h and t, right? So the gap, we call this is the second line, if you still remember. Okay, the second line. And the derivative is here. So as the definition tells us, so when the limit of h getting closer to 0, what does it mean? So if this gap is h, has h in x-axis, so as h getting closer to 0, meaning it is getting closer from the from B to A. So as it's getting closer, then, for example, if I write this point here in A, so this is my derivative. Okay, it's calculus 1. Okay, but it's just translated to this calculus and change all the terms with r. So the r prime is we call it is a vector tangent, the derivative, to the parametric curve. The parametric curve is the blue line here, the blue curve. So the vector tangent is at the top of the vector functions and points in direction of increasing parameter. So if the function of t of f, g, and h, if all differentiable, then our derivative is simply just derivative of h functions. So the proof, if you want to prove the derivatives, we need to define our vector function in terms of limit definition of for derivatives. So derivative of r so for the x will be x xt plus h minus xt over h or let me combine with y. Okay. So plus y t plus h so this is I plus j, this is let me make it longer, and minus okay. So basically it's the same thing, but I write in ijk, and then grouping all the t plus h. So based on our definition of derivatives with limit, we can conclude that this is the x prime t plus y prime t j. Yeah, the idea is just evaluating each x and y with the limit and then grouping all together. And then you will get this is the x prime. So this is all x prime, this is all y prime. Okay. So example. Let the function, the vector functions is and then let's try to derive. No.
So I'm integrating out direct. Oh, that was okay.
Okay. You don't mix up with the integrations.
I was like,
Okay. So this is, we call the tangent vector. So whenever you find how to find the tangent vector, what does it mean is you need to derive the vector functions, and this is the tangent vector. Okay. And then you have also the terms tangent line. Oh yeah, plus. Yeah. So tangent line is line through some point, maybe P, and it's parallel to R prime T. It's the same thing, right? Just to change all the terms with factor. The difference is, however, in vector you have the unit vector, right? So we have also unit tangent vector. We call this in terms of T, the big T with capital T. This means unit tangent vector. The definitions is the vector of the derivatives, okay, divided by the norm or the magnitude. You can write the magnitude with one line or two lines, the same thing, doesn't matter to me. So if the question is the same, like the 1 over t plus e to the 2t, blah, blah, blah. So if you need to find unit tangent vector, at t equal 1, so we can use 1 and then evaluate all derivatives and the norm with t equal 1. So negative 1 and then to e with 2 pi, it's 0, right? 0. And then to calculate the norm, you need to square root and then plus the squared, right? Squared. So this will be 1 plus 4e to the 4th. Yeah. So it depends on you. You want to calculate and mentioning the decimals or not. It's up to you. I prefer not to calculate that much. I hate the decimals. So let's just write the answer as this. So this is the unit tangent vector at t equal 1. Just example. Hmm? 0. I think it depends on domain also. You need to find the domain in the whole. Yeah, it depends. This is just an example. Okay. Okay. Next, I hope you still remember the factor the parametric equation and all. I will give you example. Find parametric equation for tangent line to the helix with equation x equal to cosine t, y sine t, z equal t. At 0.01 pi over 2. So you need to find the tangent line. Okay. So first, you need to understand the question first, right? Do you understand? No. So you need to find the parametric equations, okay, for tangent line. So you need to find the tangent line, and you need to find the new parametric equations. Yeah. Helix. So helix means the shape of the vector functions will be helix like that. So usually, if the base has a circle, and it will level up as z increasing, you will have helix. So first we write the vector functions is 2 cosine t, sine t, and then t. Okay. Let's just find the derivatives for finding the tangent. So derivative, so cosine will be minus, right? It will be cos, it will be 1, right? And we need to find the tangent factor, right? Tangent factor is when we plug in some value. Which value? This value. So from this point, we see that our t is pi over 2, right? From z equal t is pi over 2. Our point is 0, 1, pi over 2, right? So we can plug in t equal pi over 2. No, because 1 will be sine t. We have these vector functions, right? Vector function is 2 cosine, sine, and t. If you want to plug in 1, so in this case, 1 should be equal sine t. So t is pi over 2, right? Right? Okay. 0 is 2 cosine t. So t is pi over 2, right? Cosine that has 0 value is pi over 2. Okay, it's all correct, right? So we need just to plug in t equal pi over 2. We will get negative 2, 0, and it's just number, it's constant 1. We call this is our tangent factor. So my vector functions will be, let's just say we start with the initial point of 0, 1, pi over 2. We start from that. Plus t so x will be negative 2t, y will be 1, z will be pi over 2 plus t. So this is the parametric equation for tangent line. So the idea is to find this tangent factor. And then plug into this equation. So it's similar to our factors. In factors, you have this, right? In chapter 12. It's that the same equation. But in general, you can also write a general equation. So the question is solved up until here, but you can also write for general tangent line. You can write x is -2 So if in general in any terms of t, okay, this is just a general term in any t. This is the initial, right? This part is initial. This is the tangent factor. Okay, so don't forget the definition for parallel and then orthogonal. Okay. All the property of factors in chapter 12 will be used in chapter 13. So this is chapter 13. So actually these questions you can directly calculate through the point, calculate each tangent factor, the exact value, or you can go to general tangent line and then plug in t in that general tangent line. Both are fine, but I prefer just the first method. You just calculate the exact value and you get the result directly. It's the same. You can approach with two methods. The first one you calculate the value. The second one you calculate the formula first and then plug in the t. So what you will do is after you get this general tangent line, you plug in t equal something, right? In this case, pi over 2. So you plug in pi over 2, you will get the same result as the answer. Okay. So the next part, I will write some property. Okay, some property. If R and S is the vector functions, so R as a vector function. So R plus S you can write this as R prime plus S prime. If I write the blue color, meaning it's also the same case with when you subtract. Okay. Secondly, if you have a constant, let me write with the arrow so you can differentiate the constant and the factor. If you have So this is the dot product, okay, because we are in the vector, so you can have all this property. And if you have any function and if you have the function is inside the vector functions, you can use the chain rule also, similar. So you derive the function inside, and then some notes. If yes, f is a function, c is a constant. S accent. So this is the formula. You can use this and calculate the value. But for dot and cross, my suggestion is if you have any dot product, you can dot product the inside first and then derive. It will be the same result. Same result. So yeah. So my suggestions for dot product and cross product, evaluate the dot or cross and then derive. Time. It's chain rule. So C is a constant, F is a function. I write all the property, but my suggestion is for dot and cross, don't use this. Just dot and cross the value first and then derive. So if example, okay, so if I have R1 and I have R2 so calculate so this means the dot product Let's try our formula. This is just to show you that the formula working. It is working. So R1 prime, or let me write the derivative here. So it's 2I plus 60 plus 3t squared. So R1 prime is 60 and 3t squared. And you need to dot with the R2 is T4 plus R1 is T2 2t 3t squared t cubed, and then the same it will be let me move here the equations. So 0 0 so 0 0, so 3t6 plus 4t6, it will be 76, right? This is the first method. The second method, you can just dot the R1 and R2 directly. So first dot these two factor 2t it will be t7, right? So this is so if I derive this, so I'll get the exactly the same, much faster, I think. So that's why I'm suggesting you just dot the product and then derive. Okay, finished? I'll give you examples. So the graph of R1 and R2, both are vector functions, intersect at the origin. So find the degree measure of acute angle. So finding the angle between the tangent line to the graph of R1 and R2 at the origin. So R1 is tangent in first t, so in the last 10 minutes I will deliver the midterm to you, the results, after we finish some examples. So the question is asking, you need to find the degree of the acute angle. between the tangent lines of R1 and R2. So you find the tangent line of R1 and R2, and then to find the degree, how you are doing that? Any idea? So you need to find, if this is R1 prime, this is R2 prime, you need to find this theta here. Remember that both of this is a vector. Yes. So let me just write the R1 prime. Let's derive the first equation. Tangent inverse derives. Remember, what is the derivative of tangent inverse? Yes. What? 1 over. But here is t, right? So we change to t. And the sine is cosine t, and then 2t. Two. Ln t. Okay. And then see the questions. They both intersect at the origin. So what origin means? The x, y, z is 0, 0, 0. But it depends on t, right? So we need to find t that makes the equation 0, 0, 0. So the origin, for R1, the origin is when t equal? No, the equation, not the derivatives. Zero, yeah. For R2, t equal 1. So we both evaluate both derivatives with t equals 0 and 1 for each R1 and R2. So R1 will be 0, R2 will be 1. So R1 prime 0, it will be 1, 1, 1, 1, and then 0, right? And then R2, oh wait, 1. So 2 minus 1, 1, 2, 1, right? And then we can go by this definition, right? So we can write the cosine theta is a dot b, or in this case, R1 prime dot R2 prime over the square so 1 multiplied by 1, 1, right? Plus 1 and 2, 2, right? Over, yeah, plus 0, and over 1 plus 1, 2, and then 1 plus 6. So this is, or you can So theta is pi over 6, right? Right. So why pi over 6? Because it's acute angle. So we only take the less than pi over 2. I think one more questions and then we can finish and I will give you your results. Midterm. The result. I think most of you did a good job. So basically, the calculus is it's only mainly derivatives and integrations, right? But the difference is between calculus 1 and 2 is the perspectives you use, right? Limit is you just plug in the limit, right?
It's not easy.
Easy. Limit is just like you want to get closer to one person, but you cannot get close to that person. You always get some small gap.
Close but not close enough.
Yes.
That's like my relationship.
Yeah.
School is a waste of time.
Okay. One more questions. Find the point on curve with the t is only from 0 until pi, where the tangent line is parallel to plane so your r is 2 cosine t. So the tangent line of the curve is parallel to this plane. So we need to find the tangent line. And then, because it's parallel, remember that it will be having an orthogonal with the plane, right? So I will write tangent some notes here so that you remember. So tangent line to the curve, it's parallel to plane when curves tangent factor is yeah. But basically, you can visualize any curve, and then you have a tangent line. You have a plane. You have a normal factor. Then the normal factor will be having an orthogonal with the tangent line itself. So let's evaluate the derivative of the r. 2 cos t and it's same e to the t. So orthogonal means it's 0, right? Because cos orthogonal means cos pi over 2 is 0, right? So the plane itself, okay, the plane itself, the normal is 3, 1, 0, right? So we can dot these two. So dot square root of 3, 1, 0. So it will be plus 2 cos t plus 0, right? So it should be equal 0. It's 0. So you rationalize this, you get this number, which means t is pi over 6, right? The tangent is 1 over 3, square root of 3. So t is pi over 6 because our boundary is from 0 to pi. So between these two numbers. So the point, don't forget to plug in the point, okay? Plug in the t to the point, so because it's finding the point. So the point will be, when we plug into the 2 cos pi over 6, this is the vector. So the point is, just evaluate all the t here. Or I will write point P is 3. Okay. Yeah, well, I think I'll finish under here. I will deliver you the midterm, and you can check first, and then you can ask me if there is a mistake in the calculations.